And joining us now here in studio, Marie-Yves Bélanger, coordinator at the Think Tank Lab, and Jonathan Guberman. He's co-founder and board member at the Site 3 Collaboratory. Welcome to you both. I want to just spend a second here on the names. You're not a think tank, no. You're a thing tank. Okay, let's get that straight. And yours, I see obviously this is a play on collaborate.
That's
You're
right.
a collaboratory, and this will all make sense as we go into this. Marie-Yves, let's start with the basics. You're part of this maker movement.
Yep.
What's a maker?
What's a maker? A maker is an independent hobbyist, tinker, creator, and we normally organize around these maker spaces. These spaces where you'll find all the tools that you need, all the equipment that you need to create prototypes, products, devices, things from beginning to end.
Jonathan, what do makers make?
Makers make whatever they want to. At Site 3, we have people who work with electronics. We have people who work with leather. We have people who work with fire, with fabrics, with wood, with all sorts of things.
Okay. People have been tinkering in their living rooms and bedrooms and garages and basements and so on forever. So what makes this movement different?
I think there's a strong emphasis on technology, on new technologies that are now freely available. We do have a lot of industry-grade technologies and equipment in our spaces, but you'll see also this movement of open source hardware. So cheaper equipment readily available to all the makers, and it's easier to get a full product out the door from start to finish and to do everything by yourself.
Just explain, open source hardware means what?
It's hardware that can be actually tinkered upon, can be adapted, can be improved. It's a little bit like open source software, which you can download freely on the internet and also adapt to your own needs. For hardware, you can download source file, you can download blueprints and actually recreate, for instance, a microcontroller, a little computer. You can actually rebuild it by yourself.
Huh. Do you see this as new, Jonathan?
I do. I see the open source part of it as very new, and I think that's what perhaps is fundamentally different about the maker movement now from people tinkering in basements and garages. In another very real way, it isn't all that different. It's just that it's become a lot easier. With the internet, we can communicate with people all around the world rather than just people who happen to be in your immediate vicinity. And the other difference is that I think people tinkering has been in decline for a while until it has started rising again, and that's possibly for economic reasons, for space reasons. I don't have a garage or a basement to tinker in, otherwise I might use it. So in a lot of ways, it isn't that different, and it's worth remembering that people have been doing this for a long time too.
Okay. Look on the monitor over my shoulder there, and we're going to show the Canadian Maker's Passport. Marie-Yves, what is that?
This is a passport that we created over at Think Tank with the help of a lot of other makers in Canada to basically come together as a community. So you'll see right now in Toronto there's many makerspaces popping up, and there's a lot of makerspaces all the way around Canada, and we decided to come as a community with this Maker Passport. So you can go to a makerspace anywhere in Canada and get your passport stamped. And
what do I need the passport for?
It's just it's a playful. It's a take on the community that we have, and you don't really need it necessarily, but it's to show where you've been and the places that you've seen and the people that you've made with as well.
So kind of a good housekeeping seal of approval?
Exactly.
That kind of thing?
Yeah.
Okay.
More even just bragging rights,
yeah,
right?
Exactly.
Bragging rights. Oh, okay.
I know recently my wife and I were on vacation in Maui, and I visited the local makerspace there, and they asked me if I had brought a passport for them to stamp, and I hadn't, unfortunately. But,
so these are everywhere?
Everywhere.
It started
Everywhere
in the
world.
It started in the United States with Mitch Allman's first Maker Passport. So this was the passport that inspired the Canadian passport, and it's been taking off. Definitely, I've made my files available for download on the Maker website, Maker Passport website, so that other countries can make their own passports.
Okay. Now we're going to show a clip. Again, take a look at the monitor. Jonathan, you'll recognize this. Roll tape, please.
Activated. Uh-oh. There you are. No hard feelings. Target acquired. Hey. Hey. Are you still there? Hello, friend. Why? Hi? Whoa. Sorry. We're closed.
Okay, what is that?
That's a little plush toy of a character from a video game called Portal. it's a game that I really enjoyed. The first video game really that I've played in years. And these characters in it are they're robots who are trying to kill the main character. But they say all of these sort of things in that sing-song voice that you heard, and it's very funny. And I loved the characters, and very much like when I was a child, I wanted one. And I knew that I could make the electronics. All of those things you saw the hand doing in the video, those are sensors. So in the game, it says certain things if you pick the robot up or knock it over or go in front of it. And the toy does the same things. It can sense if it's been picked up or knocked over or if you're in front of it. I can't sew, I can't make a plush toy, and that's where the collaboration comes in. I sent out an email to my friends at Site 3 and said, who here knows how to make a plush toy and wants to do this with me? And Lee Noonan, who did all the sewing and made the pattern, came up with that and sewed it together, and I put my electronics inside it and put it up on the internet, and 500,000 people viewed it. Okay,
a silly, old-fashioned capitalist question here.
Yes.
Did Lee get paid for doing that?
Lee didn't get paid for doing it. I didn't get paid for doing it. Lots of people wanted to buy it from us, but it's not our video game, so we can't sell it. The video game manufacturer wasn't interested in giving some guy the rights to their creation. Right. You can now buy a very similar commercially produced one. They, a few months after I posted mine, they put something up very similar that you can buy for $29.95 online.
Okay, because I'm trying to understand the economics of this. You know, you got an idea, you ask some guy to basically contribute his labor for free to get this thing. Lee's a woman. Okay.
Yeah.
How does anybody make money on it?
No one made money on it. We just did that for fun. Was, you know, she liked the game. I liked the game. A sequel was coming out, and we thought, why not express our fandom by making something cool?
Gotcha. Let's do one more, shall we? Roll tape, please.
Super Street Fighter is designed to be a totally immersive experience for the player. They step onto these platforms and into a totally different world where they put on these incredible motion sensing gloves that allow them to send waves of fire back and forth at each other like they had superpowers.
It was an idea to take fire and come up with a way to manipulate it with your hands, but in a way that's both safe and fun.
Safe and fun throwing fire at each other.
That's right.
Okay, explain this to me. How does that work?
Well, so you're not really throwing fire at each other. You're standing in a ring, and the fire is going around the outside of the ring based on your motions. I hope the fun part is self-explanatory.
Not quite. Explain this to me again, how exactly you play with fire but don't hurt anybody?
So you have a ring of jets around the outside of the play area, and two people are standing in the middle of it, and based on their motions and actions, the flames on the outside, they activate. So they're all shooting up, but you're in the middle. So it's not going anywhere near where the people actually are. There was a very similar mechanism that Seth and his team had at Nuit Blanche for the past 2 years, actually. Last year it was the Heart Machine, which was near, I guess, Yonge and Dundas. And then before that it was called, the name's slipping my mind, but it was a similar project. Only in that one, people stood on a platform and danced, and based on where they were dancing, flames on the outside activated. And no one got hurt. My then 13-year-old cousin did it and loved it at Nuit Blanche, so I don't think I would have sent him in there if it wasn't safe.
Okay, moving right along. You mentioned this already, Marie-Eve, this makerspaces, I think was what you call it. What is that?
Makerspaces are spaces where you'll find us congregating almost on a daily basis. This is where, this is our cave, our bat caves in a sense.
Your bat cave.
This is very reminiscent of the mythical Silicon Valley garages where the HPs and Apples of the world kind of took off.
Okay, but the bat cave is a secret place and no one knows where it is except Alfred.
People do know about it because they're flocking to our spaces. This is where we have our events. We do have a big educational mission over at Think Tank and also in most makerspaces as well, where we gather to have workshops, to have learning events. But this is also where we have our different technologies and tools. So for instance, we have a lot of high-grade prototypers over there. So I'm talking about 3D printers, laser cutters, computer-controlled mills. There's also kind of the homebrew version of that, so the open hardware that I was talking about earlier. And then you have traditional toolings, and I think you spoke to that effect as well. So everything like welding or woodworking, we have those tools as well in there. And then everything that is crafting and sewing and leather working. So this is where we keep our tools. We also have our workspaces. We have benches over there to basically assemble those products.
So it sounds sort of like an artist's commune in a way. It has that feel to it.
It is.
Everything is open for everybody to use?
To our members, definitely.
To your members.
So there is a membership to most spaces. So the fees really differ, so from $25 to $100 a month. It really depends on the space and what they are offering. Most of the space have opening hours from 9 to 5 or a bit later, and they do offer a lot of kind of tutorials and learning as well as part of the deal. So you have access, you share the space, you share the equipment, and you share the learning as well.
You say share the learning. What do you learn?
You basically learn a lot about how to use these technologies. You learn about the opportunities that these technologies can give you, and it's really an inspiring space. We meet up a lot with each other. We have these nights called Open Lab Nights, where we actually tinker together. We each bring our own projects, but we work together in the same environment. It's a bit like co-working, but for physical makers. And then we also learn from each other by having workshops and on how to use proper technology, how to use fire properly.
Yeah, which is a good idea. Yeah.
Yep.
So there's a sense that you sort of feed off each other, is that right?
Absolutely,
yeah.
Absolutely. Like I mentioned before, if you don't know how to do something, there will often be someone there who does. And the breadth of experience that we have in our community and that many hackerspaces have in their communities is incredible.
Sorry, hackerspaces?
Hackerspaces, makerspaces, same thing.
Same thing.
Yeah.
Can I ask a real pedestrian question here?
Sure.
Does anybody make money doing any of this stuff?
Yes.
They do.
Some of them do.
Absolutely.
So what you'll see in terms of work, you see a lot of fun experimentation. You'll see a lot of art as well, but you do see products come to life from start to finish. One of the biggest one of the big success stories is actually the MakerBot Industries, which grew out of a makerspace. And the MakerBot industry is actually producing those open source 3D printers called a MakerBot. And right now they've been funded last year for $10 million. So this is nothing to laugh at, really. There's something in there. And there's been a lot of repercussions as well on other industries. So I've been reading in Forbes yesterday how rapid prototyping industries such as the laser cutter industry as sales of $7.3 billion right now in 2012 because of the whole maker movement right now happening.
Okay, now this is, I'm asking these very old-fashioned questions here because
right.
I'm brought up in a very old-fashioned time, but with all of these people doing all of this kind of intellectually interesting work all in the same space, do you not worry that the guy sitting beside you is peeking over your shoulder and stealing your idea?
Not really, no. Like Maria mentioned earlier, part of the sort of philosophy driving the movement is open source. And so for a lot of people, I know for me, when I'm done with the project, I'm going to release all the plans and schematics anyways. And so if other people want to copy it, they're welcome to. I am not making money off of it, I'm not trying to, but there are companies that do, and they release their plans as well. And the way they make money is usually through economies of scale, in that for electronics, if I design and build something, I can give you all the schematics, you can go out and have your own circuit boards made, but chances are you just want to make one. And if I'm making 100 or 1,000, then I can add a nice tidy markup to that, and it will still be cheaper for you to buy one from me than to assemble the parts for just a single unit on your own.
So it's really old thinking that says this is my intellectual property and I have to protect it and not let anybody else see it.
Definitely. It's about open source, it's about open innovation as well. It's about redefining what IP means and how we think about ideas. Ideas are worth nothing if they're not implemented, if they're not made, and the physicality of those projects and of those products is what makes an IP legitimate in a way, and that's what we see at the lab as well. We are distinguishing ourselves from the other makerspace a little bit in the community because we are focused on getting products to market, because we do see value in the open innovation, and then what we do is actually try to foster that business sense as well in makers and in hackers, and trying to actually push products to market.
Well, some people think this is a very big deal, and I know we had Jeremy Rifkin on this program many times in the past, and he recently said that the maker movement is, quote, as significant as the shift from agriculture to early industrial age. Does that sound a little over the top to you, or what do you think?
Well, we're right in the thick of it, so we're biased. I don't think it sounds over the top to me. I think that the biggest potential is coming from the 3D printing sector, which Maria talked about earlier with the MakerBot and other 3D printers. And I don't know if that's something that all your audience is familiar with, but the idea is basically that you have a printer that, rather than putting ink onto a page, can build something in 3D, usually out of plastic. But there are more sophisticated ones that can work with other materials like ceramics and metals. And you can design something in 3 dimensions on your computer and then press a button, and a couple hours later you have that object in whatever material you can print in. And this...
Take a look. What are we looking at?
So these are a couple of examples that we printed at the lab. So this is exactly what we're talking about. So the technology is almost exactly like a glue gun, layering plastic layer by layer. And so you see a couple of Christmas trees, and you see a bracelet and a couple of gears. So what is great in here are the gears, because what is great with 3D printing and other rapid prototyping technologies is that we can be very adaptable. We can, it's easy to change design, and it's easy to iterate on designs. So in that way, it's a new type of industrial revolution, because we're so flexible and adaptable in our designs, and we see the rise of the small scale manufacturing as well. So we're producing one-offs, but we're also producing small series of customized designs as well.
Would you call it a 3D printer? You're not really printing, you're, I mean, there's got to be a better verb to use here.
You're depositing material. You are printing. So my bracelet, for instance, this is a 3D printed bracelet. So it's exactly what we're talking about. It comes out of
You made that on a machine?
Yeah, on a machine. So it comes out of this oven-like structure, at least the one that we have, which is a professional grade one. It's almost like an oven, and you open the door, and there you go. It's almost science fiction.
Well, you didn't print it then. You baked it. If it came out of an oven, you baked it.
It's actually there's a lot of temperature. There's a
There are those that see this movement, the makerspaces and the maker movement itself, as the new innovation lab that's going to launch the next Apple or something like that. You know, do you guys see it having that kind of potential? Can it get that big?
I don't see why not. A lot of the things that people are doing are sort of thinking a little bit smaller, but some of the most successful ones aren't. Like MakerBot, I mean, like was mentioned earlier, they have $10 million in venture capital, and their vision is really to get 3D printers like this onto every desktop in every house in the world. And suddenly, you can start imagining why that would be revolutionary, because instead of buying cheap plastic parts and having them manufactured in China and put on a boat and shipped across the ocean, you download the part and print it up in your house, and that's it. No more middleman. And people have actually done things like this where there was one story making the rounds about a year ago where someone had a little plastic bit on his dishwasher brake, and rather than writing to the manufacturer to get a new one, he just took it, made a model of it on his computer, printed it up, and put it there. And then there is a website called Thingiverse where people upload their designs and share it, and you can get all sorts of things. Little pieces for dishwashers are one, but people have printed up chess sets. Now they're inexpensive 3D scanners, so people have scanned their heads and uploaded them, and you can print out a little bust of someone else.
But it does get back to that question: how does anybody get paid for any of this? I'm sorry to be so capitalistic and pedestrian about this, but
it depends. There's a lot of making for making's sake as well that happens in our space, but it does come to what we're creating right now is this whole ecosystem as well. So we're not only alone in our little garages or little maker spaces, but thanks to the digital culture, to digital media, and to the internet, we now have tools online to help us fund our projects. So Kickstarter, for instance, has been a huge help in getting a maker project off the ground. And then you also have, for more crafty projects and more one-off or smaller runs, you have websites like Etsy where one can actually sell their products. So there is money to be made. Right now we're seeing it, especially in Canada, it's just getting started. But I think with those websites and with this ecosystem that is just growing of online communities and websites to help other makers, I think it's just going to take off from there.
There are also commercial 3D printing websites where you can print in materials and of a quality that you can't do at home. And what you can do there is you can upload a design and then pay them however much it costs to print that design, and they'll mail it to you. But you can also set a markup, and anyone else who wants to will order one, and they'll print it up and send it to them, and then you get the whatever markup you set on it. So I've done that I've designed a pair of cufflinks that I had printed in sterling silver, and I set a markup, and people around the world can buy it. And you know, I'm not paying the bills that way, but I did pay for my own pair of cufflinks that way.
Nice. Well, you can call them printers. I'm still going to call them ovens. Marie-Yves Bélanger, the coordinator at the Think Tank Lab in downtown Toronto, and Jonathan Guberman, co-founder and board member of the Site 3 Collaboratory. Thanks to both of you for coming in tonight.
Thank you.
My pleasure.
Support Ontario's public television. Donate at tvo.org.